All right, welcome to pre-calculus. So this is going to be our first lecture for pre-calc, and it doesn't matter for pre-calc with trig or without. The same. The first lecture is the same for both of you. Okay. So we're going to talk about average rate of change, and we'll see if we can't make some headway on that one. All right. So let's go ahead. I'm going to just move to the board here and the screen rather, and that way we'll be able to rate. You'll be able to see that. Okay, so what's going on? So we have, just draw your typical type of a curve here. Okay, there's a curve. What we're going to do here is we are going to get some point A, some point B, the y value of this thing, okay, whatever the function happens to be. Okay, this will be f of A, and then this guy over here, this will be f of B. So it's the y value at B, the y value of A. So what we're going to calculate is effectively what the y value at B minus the y value at A divided by, and in parentheses, B minus A. Okay, so we calculate the top, okay, calculate the bottom, and then divide the two. Have you ever seen this kind of formula before in your lives? Say that, yes, you have called this a slope before, okay? So we go back to our board here. So we've got this going on. So to make it a little bit fancier, okay, we're still going to draw the same kind of generic curve here. Okay, and what we're going to do is we're going to have our x. If you want to go old school, we're going to say x plus to x. So this value here, this is x plus delta x. Okay, now if you have a math book written before I was born, they're going to use delta x's. Okay, if it's anywhere after I was born, they stopped using delta x's and they went with h's. Okay, so anything written from about 1970 onward, they use h. Okay, so this is x plus h rather than x plus delta x. I don't know why they changed it, but that's what they did. Okay, so this is my f of x. This is my f of x plus h. If you want to, again, you want to go old school, that's okay. F plus delta x. Find a calculus book written in the 60s. That's what they're going to look. That's what it's going to look like. Okay, and their difference quotient. This is your first day of calculus, lecture 2, by the way. You're going to have f of x plus h minus f of x, all divided by, what is x plus h minus x, right? That's the difference between these two pieces here. So if you guys go ahead and do this arithmetic, x minus x is just 0, so we just have h. So the value in x is the run part. So we have the difference in y's versus the run. That's just h, delta x if you're old school. Okay, and that is what we have for our difference quotient. You're going to be provided this formula. Okay, this is not a formula that I would expect you to memorize. That's annoying with that fan. I wonder if I can do that so you're not necessarily looking at it. Okay, I'm gonna have to work on my setup here. Okay, so there we are for that. All right. All right. So there's 5 functions that you're going to be asked for. Okay, I'm going to give you difference quotient for 5 different functions. All right. One of them is going to be f of x equals mx plus b. Okay. I can give you an ax squared plus bx plus c. Now, I am not going to give you ax, like you're not going to see this as a quiz question kind of a thing. What you're going to see is something like 3x squared minus 4x plus 1. Okay, that's the question you're going to get. Okay, so A, B, and C, we're not going to do that to you just yet. That artificially increases your difficulty level. I know you're not there yet. Okay, we could also do a cubic. Okay, so we're going to have ax cubed plus bx squared plus cx plus d. This could be a very tedious problem. So again, it's going to be something like x cubed minus, say, 3x squared plus 1. Okay, that would be a good problem. Actually, that would be a terrible problem, but that would be a reasonable problem. Okay, but that's the kind of way I'm going to pitch it to you. We have rational, so you could have a f of x equals, say, something like a 2 over, how about we go with a 2x minus 5 kind of an idea. Okay. Or we could have an f of x equals some kind of a square root. So we could have the square root. And again, these get a little bit complicated and tedious. So if you put too many elements of difficulty in here, they start to get a little long. So the kind of problem you want to practice is going to be something like the square root of x plus 7, something like that. All right. And we're going to calculate the difference quotients for all of these. All right, that's what we're going to do. Now, back in college algebra, you guys learned about transformations of functions. All right. So it's important for you to remember how to do that, at least a little bit. And what we're going to do is we're going to say, well, how would we graph this? Right, this is a shift to the right of 7. So if I wanted to go ahead and graph it, we would do 1, 2, 3, 4, 5, 6, 7. And then we would graph our square root function, something like that. So we would know. Now, the reason I showed you guys this is not because, like, hey, you should be an expert at all the stuff you ever learned before. That's not what the standard is, okay? I do that, I pitch that stuff to you so that you remember, like, hey, we did learn this at one time, so we're gonna go back and redo some of this, okay? But one of the most common mistakes I get when I see do f of x plus h minus f of x all over h, after a student goes through all of this work, they come up with an answer of like 2, okay? So what you're telling me, the average rate of change, the difference quotient, the slope between any 2 points is always 2. Now you could look at this function. If I pick any 2 arbitrary points, is that slope 2? It might be, but is it always 2? Like if I pick these 2 points here, is that slope 2? And that slope is also 2? And then like another couple of points, that slope's 2? So it can't be constant. Okay, the only time it's going to be constant is when we have this first, right, this first example. So if you just have a line, if you have y equals mx plus b, right, that's the function I gave to you. The slope is always 3. Okay, so you're only going to have a constant in there. So if you do this problem and you come up with a number like 1, right, or negative 1/4 or something, and you could look at this function as like, well, he gave me something with a square in it. That's a parabola, right? That changes. Parabolas, right? Parabolas look something like this. Those slopes are changing depending on where you are in the problem, okay? So if you come up with a constant number, what that's telling me is like, or it's telling you is that the slope never changes. Okay? And in some functions, it doesn't, right? If I have, my 3x plus 2, like right there, that's there you go, right? That slope never changes. But everything else, that slope is going to change. So your answer had better have x's and h's in the answer, because it's going to depend. What we're doing is we're picking an x and we're picking an h, okay? And we're getting the slope between those 2 points. Okay, that's called a secant line. Okay, right now I won't really ask you about that. Okay, secant line is connecting any 2 internal points. Okay, if we have something called a tangent line, it only touches the curve at, say, 1 point, like this one, and it just touches it at 1 point. This would be a tangent line. Okay, so tangent line touches a curve at exactly 1 point. A secant line touches 2 internal points, and you draw a slope for it. Okay, so that's the difference. Okay, I'm going to go ahead and try to keep these to digestible bites of information here. So we are going to do some examples in a little bit. Okay, okay, talking about all of 5 different things, okay? Now, the first one, I'll just go off and tell you right now. What's the slope of any secant line for y equals mx plus b? It's n. That's right. Because the slope is a constant. It's always the same thing. I'm never going to ask you this question. I mean, it's a potential one that you have to know, okay? But I am never going to add, like, if you get to a quiz question, and I've asked you this question, you should ask, like, is this guy okay? Because I'm not going to ask you this question, okay? Similarly, if you get a constant as an answer, you know you've screwed up, okay? Because you're not going to get this question. Okay, it's too easy. You guys are in pre-calc now. You're grown. Like if you were in intermediate algebra and I ask you what the slope is, that's one thing. You're not in intermediate algebra. I'm not going to ask you this question. Okay. So just be aware that if you only get like one small, tiny little thing, one answer, one numerical answer, like one, you've done something wrong. Okay. So I'm going to go ahead and stop here so that I can check some things, but we're going to go through parabola, a rational, and a square root in the next video. Okay, so thank you for coming, and I'll see you in just a moment.